Hi everyone, my name is Laminda and I'm revisiting the Spaceship Interface project that I've completed previously. The goal of this project is to create a computer module that controls a series of lights where there's a green LED and then two red LEDs, and when the switch is not pressed, the green LED should stay on and be solid. However, when the switch is pressed and held, the two red lights should turn on and off between each other. This project is called the Spaceship Interface, probably because it sort of simulates a crew station in in a spaceship or an aircraft where the crew member is responsible for transmitting distress messages of some sort. So, for example, say the aircraft is flying normally, then the green LED should stay solid. That indicates that the spaceship is flying normally and under normal operations. However, when the switch is pressed, that would indicate that the airplane is in distress or needs help of some sort. So that's sort of the way I see it. You can sort of use your imagination, I guess. The components of this, starting off, we have, of course, the Arduino Uno, and then the breadboard. I have the red wire here. It's connected to the 5-volt pin and going straight into the power rail. The black wire, you can sort of see it. It's a little hard to see, but there it is. The black wire is connected to the ground pin and going into the ground rail. The LEDs, each of the LEDs are connected to three 320 ohm resistors. Sorry, each LED is connected to one 320 ohm resistors for a total of three 320 ohm resistors. The switch here is connected to a 10 kilo ohm resistor. The right side of the cathode for each of the LEDs are connected to the wiring. This red LED is connected to the 5-volt pin. This red LED is connected to the 4-volt pin. And the green LED is connected to the 3-volt pin. Now, the are connected to, so these pins here are the output pins, whereas the switch pin is a input pin. And that makes sense because the switch should be our input because we're actually manipulating that. So when you press it, that should be your input, and that should transmit a signal to manipulate the series of LEDs. Now, going over the code for this program, the first thing you have to do is you assign a variable. In this case, I've set it to 0, and that is just saying that the switch, when it is 0, that indicates that basically the switch is off. In other words, this switch state variable here represents the status of the switch. Now, using the void setup function, down here is where we actually assigned the pins to their respective outputs and inputs. So as you can see, like I said earlier, the 3 to 5 pins are the output pins, and that makes sense because those are the LED pins, or sorry, those are the LEDs. And then the pin number 2, as you can see, is connected to the switch, and that should be our input. And so, like I said before, when you press the switch, that's your input, and the LEDs are your outputs. And this setup here, this setup function here, actually only runs once, and it runs at the very beginning of the code. And it's closed within these curly brackets here. So this is the setup code here. Once that runs, then we go on to the void loop function. And this loop here is actually what runs continuously. And it's started by this curly bracket, and it's ended by this curly bracket all the way down there. So the first line of code in the void loop is the switch state again, and I'm setting that equal to something called digital read, and then 2. So the 2 is actually for the pin for the switch. So number 2 pin for the switch. And what this does is it essentially reads the voltage in the number 2 pin, and based on the switch state, based on the voltage of whether there is voltage or there isn't voltage in the switch state variable, the corresponding functions will be outputted below. So when the switch state is equal to low, that means that the switch is off, and the green LED here, which is in pin number 3, is on, which is indicated by high. Now, when the switch state, so if I sort of go down here really quick, it's reciprocated. So in this case, when the switch state is high, because this is basically an else, this is a function, so it's like an if-then statement. So if the switch state is low, then you do this. However, if it's not low, when it's high, then you do these lines of code. So down here, the number 3 pin, which is the green LED, is off. And that's when the switch is depressed, because that would mean that the switch is in the high mode, essentially. And so as you can see, when I go back up here, when the switch is low, again, the green LED is on. However, the 2 red LEDs are off. Go down here. This is saying if the switch state is not low, then do this stuff. So basically turn the green LED off and turn the red LED off and turn the number 5 LED on in this instance. But also in this else function, as you can see, it's closed by these curly brackets here. In this else function, there's this thing called a delay, and this 250 here is 250 out of 1,000 of a second. So basically, it's a quarter of a second is what this 250 is. So it's running through this code, and then once it gets to here, it goes from this number 5 LED going from high to the number 4 LED going to high and the number 5 LED going to low. And this is just looping back and forth. And there's another delay in between this line of code going back to this. And basically what that's doing is it's delaying the red LEDs from turning on and off, basically. So when one turns on, there's a 250 millisecond delay, essentially, between each of the pulses. And then the last thing, like I mentioned before, is just that the curly brackets close off. So this curly bracket closes off the else function. So I guess to reiterate, the loop will run, and then if the pin does not have voltage in it, then it'll just run this. It'll just consistently run this. However, when the switch is depressed, meaning when the switch state is high, it will do this, and it'll actually loop this as long as the switch is depressed, right? So if I hold the switch, the green LED turns off and the 2 red LEDs pulse back and forth with a 250 millisecond delay, or a quarter of a second delay between the pulses. And that's my project. Any feedback would be much appreciated. Thank you.